and welcome to Chapter 1, Section 5, Roots and Real Numbers. A square root is a number multiplied by itself to form a product. For example, the square root of 16 is 4 because 4 times 4 is 16. We also have a principal square root. And this puts a plus or minus in front of the square root sign to represent both answers, because -4 times -4 also equals 16. So both 4 and -4 are the square roots. So if the question asks you for the principal root of 16, that answer is plus or minus 4. This notation shows that this could be either positive or -4. We have some numbers that are considered perfect squares. This is when a number has a whole number as its positive square root. For example, the square root of 25 is 5. This is a whole number, so 25 is a perfect square. Whereas the square root of 24 is 4.898979, and it goes on and on. 24 is not a perfect square because its square root is not a whole number. We also have cube roots. And cube root is when the base of a number is raised to the third power, and that's written with a 3 above the square root sign. And this is read the cube root of 27. And the cube root of 27 is 3 because 3 times 3 times 3 done 3 times is 27. Now, this number could be anything. It could be raised to the 4th power, and that's called the 4th root, or the 5th power, and that's called the 5th root. And they very rarely ever do that to you because that's a lot of multiplication to figure out. Occasionally you'll get a few, but the answers are usually easy and obvious. So if we go to the examples, the first set of examples asks us to find the square root of some perfect squares. And they've given us some that are relatively easy to figure out if you know your multiplication tables. The square root of 49 is 7. The negative square root of 36 is going to be -6. Square root of 36 is 6. And then the cube root of -125, that's one that we worked on in our last section. That's -5, because we know that -5 times -5 times -5 equals 125. You can have negatives in cube roots. You can't have negatives in square roots. That's actually called an imaginary number, because there are no two numbers that you can multiply together that are the same that will give you a negative number. Both of the negatives will cancel out. The next thing they ask you to do is find the square root of fractions. The square root of 1/4 is going to be 1/2, because 1/2 times 1/2 is 1/4. The square root of this number over the square root of this number. So in looking at that, I've got a negative that I'm going to just drop over there, and I'm going to find the square root of 25 is 5, and the square root of 49 is 7. Here I have a cube root. I need a number that when I multiply it by itself 3 times will equal 8. The cube root of 1 is always 1, because 1 times 1 times 1 is 1. And the cube root of 8 is 2. 2 times 2 times 2 is 8. So now what I'd like you to do is do the check it outs, numbers 1 and 2. Please push pause, work those problems, and come back when you're finished. Here are our answers for numbers 1 and 2. The square root of 4 is 2. The negative square root of 25 is 5. And the 4th root of 81. The 4th root of 81 is 3 times 3 times 3 times 3. The square root of 4/9 is 2/3. The cube root of 1/8 is a problem we just had in our other example. And the negative square root of 4/49 is 2/7. Our next example is a gardening application. And example explains about Nancy and her need for square gardens full of wildflowers. But the question asks to estimate to the nearest tenth the side length of a garden that is 19 feet squared. Now here's where we need to understand roots. If I'm looking for a square root that's near 19, I know that 4 squared is 16 and 5 squared is 25. So I know that the square root of 19 is going to be between 4 and 5 somewhere. And yes, you can do it on your calculator, but I'm asking you to do it the conceptual way because it stretches your brain a little bit, and it's a good idea to understand the concepts that you're working with. If you get out your calculator and you try 4.5 squared, which is where I would start, you're going to get 20.25, and you're going to try and get closer to 19 than that. So we're going to try 4.4 squared on your calculator, and that gets you 19.36. So let's try 4.3 squared. That gets us 18.49. This is 36 hundredths from 19. This is 51 units from 19. So this would be the closest tenth. So our answer is about, that's an equal sign that's wavy, which means about 4.4 feet on each side. So now you try the check it out number 3 that has to do with the length of a cube. Please make sure you realize it's cube. Push pause and come back. So if we have 26, we're looking actually for the cube root of 26. What comes closest? Well, I know that the cube root of 27 is 3. And the cube root that's the next smallest, which would be 2, is 8. And 26 is awfully close to 27. So I know that my number is going to be pretty close to 3. And the question is it going to be 3.0 because we have to go to the nearest tenth, or is it going to be 2.9? So we put 2.9 times 2.9 times 2.9 in our calculator, and we get 24.389. And I know that if I put 3 in my calculator 3 times, I'm going to get 27. And the question is, what's closer to 26? This one is only 1 digit away, where this is 1 plus a bunch away from 26. So our answer is actually 3.0 feet. The next thing your textbook gives you is a list of all of the classifications of real numbers. Natural numbers are the counting numbers, 1, 2, 3, the ones you learn in kindergarten. Whole numbers are when you add a 0 to it, so it's 0, 1, 2, 3, and that's it. That's the only difference between these two. And then if you add the negative numbers, so you go negative infinity through 0 to positive infinity, then you have the integers. Then, if you have parts of numbers, those are called rational or irrational numbers. And the question is what the difference is. Rational numbers include terminating decimals and repeating decimals. So these are numbers that can be defined as something over something else that ends like 3/5, which equals 0.6. That's a terminating decimal. Or a repeating decimal. 1/7 is 14285 157, and it repeats that. So terminating decimals and repeating decimals are both considered rational numbers. Irrational numbers are when you have a decimal that goes on and on that does not repeat. Pi, 3.14159, and it keeps going on, and it does not repeat anywhere, and it does not end anywhere. This is an example of an irrational number. There are a number of examples of this, but this is the one I know by heart. So, your next example starts asking you questions about this, and it shows you a chart that helps you kind of understand them. So if you work through example 4, 8/9, and if we start at the top, 8/9 is a rational number because it is a repeating decimal. If you put 8 divided by 9 in your calculator, that decimal will start to repeat. So it's a rational number. It's also a repeating decimal. The number 18 is one of the counting numbers. So it's a natural number, and it's a whole number, and it's an integer, and it's a rational number. And of the two parts of a rational number, it's a terminating decimal because it stops. The square root of 20 is 4.472135955, and it doesn't show any signs of repeating. It's not a terminating decimal, it's not a repeating decimal. That makes it an irrational number, and once it's in this category, you're done, and it doesn't have any other things that it can be. Take this chart and these rules and apply it to check it out, number 4. Push pause and come back when you're done. So 4a is 7 4/9. This is a rational number that is a repeating decimal. If you do 4 divided by 9, you will get a decimal that repeats, but it's none of the others. B is -12. -12 is an integer and a rational number because it's a terminating decimal. There are no decimal points after that -12, so it terminates. 4c is square root of 10. Square root of 10 is a decimal that does not repeat and it does not terminate. That makes it an irrational number. Square root of 100 is 10. And 10 is a counting number, so it's a natural number, and it's a whole number, and it's an integer, and it's a rational number with a terminating decimal. So it's all of these things. I am not asking you to memorize all of these. I am asking you that if you are given a list to look at, can you determine what the numbers are? So don't worry about memorizing these, but I do need you to understand the concepts. If you have any questions about these concepts. And now we're on to the homework. For chapters 1, section 5, which homework starts on page 35, we're going to do numbers 23 to 36 and numbers 41 to 50. Please take extra care in the problems that are designed to make you think and apply what you know to the problem in front of you. Those are the ones that actually feed your brain. If you have any questions about these, just ask. Give it a shot first, see if you can come up with an answer, and then ask. Thank you much.